All right, so today and tomorrow we will be looking at applications of using these exponentials and our logs. So remember that our logs and our exponentials, they are inverse functions. So that means that we can use inverse operations to get from one to the other. So whenever we are creating these functions, we need to be mindful of like what is going to be happening, what is going to be growing versus what is going to be decreasing. So the main words that we're looking for when setting these up are like the value is decreasing, the value is increasing, losing value, gaining value, depreciates, all of that. So I'm going to be doing the 4 that are highlighted here, leaving 5 of them for you to do, and then of course the notes pieces for each one. So there are some formulas that go with each of these types of questions. The first one is an exponential growth question. So that means that we are gaining value of some sort. So on this first set of problems, our quantity will exponentially increase over some amount of time. So when we're writing in the formula, we've got the amount after that time will equal a times 1 plus r to the power of t. So a, that little a, is the initial amount, the initial value, whatever they say you started with, that is that lowercase a. R will be your rate of increase as a decimal. So a lot of times they'll give you a percent, and they'll say, hey, this is increasing at a rate of 4%, whatever it is. You need to change it to a decimal. And then t will be the number of time periods. So a lot of times it's going to be given in years. So we'll do number 1, and then y'all will do number 2 for homework. So on number 1, it says the original value of an investment. So original value, or keywords here, is $1,800 if the value has increased by 7% each year. Write an exponential function to model the situation. Then find the value of the investment after 15 years. So we've got this investment that the original value was $1,800. So we want to write our exponential. So the initial value is 1,800. And then this is increasing, so 1 plus the rate. The rate is 7%. And remember, when we move to a decimal, we're going to take the decimal, move it twice from a percent. So we've got 0.07. Oops, sorry. Got ahead of myself. So 1 plus 0.07, and then to the power of the number of time periods. So for now, we're going to leave it as t because it says just to write the function. And then we're finding the value after 15 years. So the amount after 15 years would equal 1,800, 1 plus 0.07 to the power of 15. Now, whenever you're solving for a value and you have this long function that you need to use, don't try to be a hero and go, okay, well, 1 plus 0.07 is 1.07 to the 15th power. Let's put that part in the just put the entire thing in the calculator. Like exactly as you see it. Put 1,800 parentheses, 1 plus 0.07 parentheses, power of 15. And this is an investment. Its value is in money, so we're going to leave the answer in money. And so we've got dollars, and it says after 15 years. So when we put that whole thing in the calculator, we get 4,966 with 26 cents. So then you guys will do the same thing on number 2. The only difference that you need to be aware of with your answer on number 2 is you're finding the number of students enrolled. So whenever you get your answer, round down to the nearest whole number. So for example, if you got 205.67 kids, you can't have 0.67 students. So you would say your answer is 205 students, because you can't round up and say we would have 206, just because we don't have 206 whole students. So we would round down and say 205. So just be aware of that on your answer on number 2. Since our answer was money, we could keep the decimal there. Since your answer will be people, you have to round down. So on the next group, we're doing exponential decay. So on these, the value is decreasing. So we've got a quantity exponentially decreasing over time. And what's good about the exponential growth and decay is that they use the same formula, except one is minus and one is plus. So whenever you see decay, decreasing value, then you're going to have minus. Whenever you see increasing value, then we're going to have plus in between. So it's the same formula, just one minus and one plus. So the values are all the same for, not the values, I'm sorry. So the variables are all the same, where A is the initial amount, R is the rate of decrease as a decimal, and T is the number of time periods, which a lot of times is going to be years again. On number 3, we've got an investment of $12,000, losing value at a rate of 4% each year. So first we want to write the exponential model, and then we'll find the value after 9 years. So we're going to write our exponential model first. So the amount after some amount of time will equal our initial amount times 1 minus that rate as a decimal. To the t power, where t is the number of time periods, and in our case it's going to be 9 years. So the amount after 9 years will be 12,000 times 1 minus 0.04 to the power of 9. Again, put that entire thing into the calculator the way that you see it. So don't leave any part of it out. Just plug that entire thing in, because you're going to get a decimal out of it. So we end up with $8,310.41. So we invested $12,000, but then after 9 years, we ended up losing money, and our investment is only worth $8,000. So then you guys will do number 4. So now we have something called compound interest, and so that's going to happen whenever the interest is calculated on the principal amount and the accrued interest so far. So whenever you are taking out like a loan or something, and they are putting interest on your interest, which is a lot of times what they're going to do, we have a different formula. And so it's A equals P times 1 plus R over N to the NT power. So P is the principal amount, which is the initial amount. It's just another way to say it. A lot of times when we're dealing with interest, we'll call it the principal. So you'll see it as that on these problems, or you might see the initial amount. R is going to be the annual interest rate. As a decimal. N is the number of times compounded per year. So it's the number of times that they're adding interest to it per year, and then T will be the number of years. So for compound interest, everything is going to be in years. So we've got per year and then number of years. So on number 5, Laura deposited $12,000 into an account that earns 8% interest. How much money will she have in 5 years if the interest is compounded quarterly? So we've got this formula. Principal amount, she deposited that $12,000. Now her rate as a decimal, we've got 8%. We're going to move that decimal twice. So 0.08 over the number of times that it is compounded in a year. Quarterly means 4 times, broken into 4s. And then to the power of that n, which is 4, times the number of years, which is 5. So to the power of 4 times 5. Again, all of that in the calculator. So putting all of that straight into the calculator exactly as it is, with that fraction in there and everything, we get a value of 17,831 with 37 cents. So if Laura deposits $12,000 today, in 5 years she'll have $17,000. And we're going to do number 6 as well. So number 6, Jack took out a 6-year loan for $25,000, and it has 4.5% interest. If the interest is compounded monthly, what will he have paid total over the course of the loan? So his principal amount for that loan was $25,000. His rate was 4.5. So we're going to move it to a decimal by moving the decimal twice. So we've got 0.045 over the number of times it is compounded in a year. It's compounded monthly, and there are 12 months in a year, to the power of n, which is 12, times the number of years. So it says for the course of the loan, and the loan is a 6-year loan, so 12 times 6 is my exponent. And again, you're going to want to plug that entire thing as you see it, as we wrote it in the calculator. And we get that he will have paid not just $25,000. Because of that interest, he's going to have paid $32,732 with 58 cents. So for that $25,000 loan, he's going to end up paying more than $7,000 just in interest. So a couple of things that I want you to be aware of. Semi-annually means 2 times a year. Bi-monthly means 2 times a month. Which means how many times per year. So I'm leaving that one for y'all to fill in, how many times per year. So that's going to end up being your N. And then compounded weekly, there are 52 weeks in a year. So just some little pointers there for the compounded problems. So again, your homework will be 2, 4, 7, 8, 9, which are only 5 problems for you to work with these exponential growth, decay, and compound interest problems.